And the invite to speak to you all tonight. As Laura said, I'm Susanna, and I'm really excited to talk to you all about data table tonight because I think it is an underloved R package. And there are many data table lovers out there, but I think there are far too many people who haven't really, given it a chance and given it a good comparison against tidyverse. So I'm here to show you kind of an intro. The expectation today is that you probably have never had any data table coding experience before. Maybe you've heard of it. I am guessing that most of you have experience with tidyverse, but would love to hear from you in the chat if you do or don't. If tidyverse is your jam, if you've loved data table before, feel free to drop some comments and, let me know where you're starting from. But I've used both, and I will be very interested in what you all think after seeing some more data table stuff tonight. Yeah, so some newbies to data table. You're in the right place, I think. Okay. And I see one person saying data table was a little intimidating. We're here to make it less scary. So we'll talk through some of those fears too. Okay. So I'm going to share my screen. So let me go to the first slide here. This slide you probably are all familiar with. This is the homepage of tidyverse. And I highlighted here one of the things that is very often said about tidyverse. It is an opinionated collection of R packages designed for data science. I really like that. I don't know if any of you have been to Hadley Wickham's talks about tidyverse, but he says that all the time. It's an opinionated way of looking at R and programming in R. But it's not the only opinion. So I like to think of data table as being one of the other opinions. So this is a section that I pulled out of their introductory documentation. And this is probably the only section where I'm just going to read to you directly from their documentation, because I think that this is really a good summary of what they're all about. So data table involves data manipulation operations such as subset, group, update, join, etc., and says they're all inherently related. Keeping these related operations together allows for concise and consistent syntax, irrespective of the set of operations you would like to perform to achieve your end goal. Performing an analysis fluidly without the cognitive burden of having to map each operation to a particular function from a potentially huge set of functions available before performing the analysis. And third, automatically optimizing operations internally and very effectively by knowing precisely the data required for each operation, leading to very fast and memory efficient code. This last sentence I love. Briefly, if you are interested in reducing programming and compute time tremendously, then this package is for you. The philosophy that data table adheres to makes this possible. So essentially, they are about efficiency in syntax and in computation time. So this is about doing things fast and having really spiffy, is spiffy the right word? Well, short, brief code that once you learn how to read it, is like you know the language and will hopefully get you there tonight. I see there's a couple chats. Let's see. Okay. If anybody has a chat that is like a question and that I miss, if one of the
It all looks like people just being excited about this talk, so you're good.
well, if one of the organizers can give me a shout
Yeah,
out,
Yeah, we
we'll do that.
definitely will.
Yeah.
thank you. Okay, so, and as I said, my favorite parts, fast file reading, which I'll show you first, and then efficient readable syntax once you learn how to read it. The data for today's examples, we are going to be using DIME data, which is from the database on ideology, money and politics and elections. I'll show you first the data that we're going to download so that you can download the one piece of data that we're going to use while I'm talking if you haven't downloaded it already. And you're looking at the DIME page right now, I believe. Yes. So the one data set on here that we're going to work with is contrib DB 1980. And you don't have to unzip it. You can just drop it in your downloads folder or some other folder where it's handy for you. Again, no need to unzip. And we're just going to be working with that today. But we'll talk a little bit about the other data and how big it is and how fun it is to work with in Datatable. So this is where I got my start using Datatable, was actually with this exact data set almost a decade ago. I was a grad student in political science at the University of Rochester, and I was working on analyzing fundraising contributions to political campaigns. These data sets are enormous, and I was not really able to work with these using the base R packages, the read.csv, any of that. And you'll see why in a second. But the 1980 data set that we're going to work with today has 458,000 rows. I'm also going to show you some examples that I previously ran with the 2016 data, which has 54 million rows. So we'll see a little bit about how the speed that we can do things with these data sets. And it is a really good set of data to work with if you're trying to learn how Datatable works and to see what operations are particularly fast. This DIME database has some pretty big data sets. So the packages for today, I think were already posted in the chat. So those are Datatable, tidyverse, tictoc, and R.utils. And so we're going to get started with some coding, because the first thing I want to look at is the time it takes to load a file, which is one of the biggest reasons to use Datatable. Is that if you leave today knowing nothing else, I hope you will at least know how to use Datatable for loading a table, because that will save you time just on its own. And you can still go back to, using it as a data frame after or converting it to a tibble or whatever you want. But you'll still save time by using the Datatable package for reading a file. So I'm going to switch over to the R Studio. So let me quickly switch over. Okay, so I've already installed the packages. I'm just going to load our two libraries that were Datatable and tictoc. And I've already downloaded this file, but I included in the code let me actually post this link in the chat if you don't have the code handy. So you can run this code here to download that 1980 data set. And again, you don't need to unzip it. And I commented this out, but earlier I downloaded the 2016 data set, and be careful with this one because if you don't have a lot of space on your hard drive, it is a pretty big file especially if you try to unzip it. So check your disk space before you try and download it. But it is fun to play with and compare to tidyverse load times if you want to take a look at that. So here we are reading files and timing them. So the first thing that I'm going to do here is we're looking at the fread function here. And just to show you what fread does, typically you would just use the input parameter here and input a file name. You might just input contrib db 1980.csv. Because we're using a file that's still zipped, I am using this command to pre-process the file. So we don't have to unzip it and then load it. We can just do it all in one step. There are other options here to specify the separator between columns, the quote, the number of rows you want. There's lots of different things that lots of parameters that you can specify here. But the great thing about data table is even if you are just using this on a little tiny file, the defaults and the inferences it draws from your file mean that you rarely have to specify any parameters at all to get your file to load without errors and without problems. It often makes better inferences than read.csv or read_CSV from the tidyverse libraries. Juliana, I see your question. What is tic doing? Tictoc is a really awesome package that just allows you to time things. So the tick, that first function starts the timer and toc stops the timer. And then the one parameter I specify there in tick is the thing that I'm timing, and you can just put in a string of your choice there. So here we're going to be starting the timer with fread 1980. That is fread for fast read, which is a data table function that we will be comparing to the tidyverse function read_CSV 1980. So when we run these two commands, comparing fread and read_CSV, we are going to get the two time comparisons of how long each of these takes. So here we go. Everybody ready? Okay, I'm going to run this set of code here to see the time that everything takes. And we got the first one done. It looks like fread here took 1.264 seconds, and read_CSV took 3.246 seconds. And Catherine, that's a good question. If it does depend on the machinery that you have underlying this, so you all may have some different speeds than I do. So curious if anybody got vastly different speeds than that when you're running it on your own machines. But you're probably all seeing that for this 1980 data set with the 400 something thousand rows, you're probably seeing a difference faster for fread. But the other thing I want to point out is we've got this warning of these problems when we were loading using read_CSV. So we'll take a look at that in a second. But before we do, I wanted to try running one more thing, which is vroom. Oh, wow, Janine, that's 3.376 seconds versus 32.11 seconds. That's a pretty big difference. So for those of you who have used Vroom before, I'm curious. Um, Vroom is another package that's part of the tidyverse that advertises that it goes way, way, way faster than any other package. Do you all have experience using Vroom before? Anybody? Yes, no for Vroom? Nope. Okay. Well, we're going to test Vroom against fread and read underscore CSV too. So Vroom, you should have, if you downloaded the tidyverse package, it should be part of what you have. So here again, we're doing tick Vroom 1980. Then we're using the Vroom function from the Vroom library. And we will be loading that into memory. So let's see how long that takes. And it was faster for me. So for me, it was 0.86 seconds. So under the fread time. Curious if you all are seeing the same. But again, we've got this warning with the problems, and we're going to take a look at what those problems are in a second and what exactly that means that we're seeing these parsing issues. So if you're following along, feel free to post in the chat what kind of time you're seeing from Vroom. So Janine, are you still seeing a faster fread, Janine? Yeah, interesting. Yeah, so not always faster. I guess it depends on the machinery you've got. But some of you are seeing some pretty fast rooms. Okay, interesting. Uh, so let's take a look at what these problems are. So we're seeing if we call the function, you'll notice in this warning, it tells us that we can use the function problems to look at what the problems are that it is finding with that object. So here I'm doing this on the using the readr library, which is what read underscore CSV is from, the problems function, and I'm uh, inputting into that the contrib db tb object, which is the one that we loaded with read underscore CSV. So let's see what we get there. And okay, well, so what this is telling us is it's telling us the row and the column numbers, what it expected to see. And in this case, it expected either a 1, a 0, a true, or a false. And what it actually received was a number. So there seems to be some sort of inference that read underscore CSV is drawing about the type of variable it's expecting to see, and it's then seeing a number instead. So let's pick out one of these rows. We're going to pick out row 458195 and look at what the actual row is in that data table that we loaded, so we can see what it's supposed to be. So again, here we are looking at row 48195, column 40, which is this one right here that it told us in the problems table was something that didn't load correctly. So we're going to look at this in the tibble version that's from read underscore CSV. We're going to look at this in the data table version, and we're going to look at this in the Vroom version and see what this particular cell looks like in each of these. So I'm going to run these 3 lines of code. Now this first one is from the read underscore CSV. That one is null. The second one here is from data table. Oh, and we see 5,650. Okay, so we're getting a number. And this is the variable name for this column, by the way, is the EFEC transaction ID origin. And then in the third one, we're getting a null. So what is it that's happening here? If we take a look at read_CSV, and oops, here we go. We need to read_CSV. I'm gonna let us take a look at some of these parameters. It has this parameter guess max, which is the maximum number of lines to use for guessing column types. If we look at the fread parameters from data.table, it doesn't have a parameter like this. So the difference between these two sets of packages, partly the speed involves how they're drawing inferences about the column types. The default for guess max in read CSV is 100 rows. So it's using the first 100 rows of the table to guess the types for everything. This particular table, again, has over 400,000 rows. So what's happening is there's some rows that are all null in those first 100 rows. Or there's some columns that are null for the first 100 rows. So then it's guessing that those are Booleans, that they're true, false, but actually they're not. They're numerical, and it gets to row 458,195. It finds a number, and it's a problem, and it doesn't give you that number. So let's see what happens if we increase that parameter and we make guess max 500,000 with vroom. So a lot of you are still seeing faster times with vroom, but here we are, we're going to say, okay, one of the things that vroom is doing as a shortcut, this like inference using the first 100 rows only. Let's expand that and then time it again and see how long it takes. So I'm going to run that now. So it's running. Okay, 6.386 seconds. Remember that fread was 1.3 seconds way back at the beginning. So now we're seeing longer times from vroom, which I know Janine didn't see this, but it is advertised to be the super, super speedy one. So essentially, when you make it so that it is actually drawing inferences from more of the rows, like fread does, it's slower. So I'm curious what you all are seeing from vroom when you increase that guess max. If anybody's seeing kind of that same super speedy behavior, or if it's now looking slower than fread. Yeah, and Cami, I see you're seeing slower. Yeah. And the interesting thing about fread is that it is looking over a larger set of data to make those inferences, but it's still able to be faster than some of these tidyverse packages. So obviously we're talking about like not a huge difference here. We're talking about, a handful of seconds. But what if we were trying to download the 2016 data that I said had 54 million rows? Now the code is in there to load it, but I would advise not running it right now because it will take a while. So I'm going to switch and show you the runtime that I got when I ran it yesterday and in loading the 2016 data into memory. So let me switch my screen share back to my slides. Okay, looking at the problems, we already did that. And then here is the time that I got loading the 2016 data. So that's 2,326 seconds with fread. That is half an hour for loading 54 million rows and quite a lot of columns of data. So I can tell you, I didn't even try this with Vroom because it's going to be on the order of 6 times larger than that. So this is something where, if you want to run it tonight when you go to sleep and wake up tomorrow morning and see how long it takes, just for comparison purposes. Again, making sure that you have enough space in your machine. But it's kind of empowering to know that like you're working with this huge, enormous data set and you have the ability to work with it on your machine. So while it's not every day that you're going to be working with the entire 2016 contribution data set, there were a lot of political contributions made in the 2016 election cycle, if you might remember. I find it pretty awesome to know that I'm not going to be inhibited when I'm trying to do a project or trying to do work by how long it's going to take to load a file. That is not a barrier. So I hope I have so far at least convinced you that maybe you need to try fread, if not the rest of data.table, which we'll now switch to talking about. Any questions on reading files with data.table? Okay. So we're going to go on now. First, we're going to clean up our workspace because, um, well, if you did the 2016 stuff, you'll need to clean up your workspace. Here is the code to evaluate Vroom on your own if you want to do that later. And now we're going to work with the data and see what all this data.table syntax is about. So we are going to be doing this with the 1980 data. So this is the same command we used earlier, loading contrib db dt. And I'm going to go back to my RStudio screen. Okay. So here I am back in the code with you. Let me just load this again so that we've got a clean workspace. And the first thing we're going to do is just take a look at what exactly is in this data, this contrib db dt. And one thing you'll notice is that when data.table prints out its contents, it gives you just the first 10 rows by default. So you get like a nice little short summary of all of the columns in the data. And you can see that we've got lots of information here about the contributors, the contributor types, contributor gender, the addresses, and then we start getting into the recipients, latitude, longitude. There's a lot of variables here. If any of you are interested in this data, we can now feel free to ask questions about it later. But there's also that Dime website has a code book and lots of information about this data set, which I love working with. But what we're going to do today is learn about the syntax of data.table. So the critical syntax for data.table is the following. There are 3 cells in data.table syntax. There's the I cell, the J cell, and the BY cell. So you'll see this syntax a lot. And what the I cell represents is the ability to subset by rows. We'll walk through some examples of this in a second. The J cell, meanwhile, is where you can select or compute columns. And the BY cell, this third one, is where you can group for computations and aggregations. So it's different than just a simple data frame where you have I and J. And there's also more functionality that you can do in each of these cells. So let's look at some examples of subset. There's two ways that you can reference particular rows in a data table. You can just do the following and look at, here we're looking at an interval of rows from 1500 to 1700. This is pretty similar to what you would do with a data frame. And if we print that out, we see that we get 201 rows. And that's what we would expect. The one thing about data table is that you don't actually need this comma. So if we run it without the comma, we get the same thing, 201 rows of the same content. So you might have seen that and found it confusing at some point. Just know that the comma, if you're only using that I cell, the comma is optional. But we don't have to just put in a row range. We can, similar to how we might do in a data frame, we can specify a vector of row numbers, or we can also use that I cell to specify an order for the rows and sort. So that's another thing we can do there. But probably my favorite thing, so here, sorry, we're ordering by the amount and we're decreasing. And that is ordering by the amount column. Now you see one of the neat things here is that we don't have to specify contrib db dt $ amount. We can just, if we use a column name within that data table, we can shorten it to just the column name itself. And this is one of the places we get that short, kind of more concise code than we would have, at least with base R. So that's one thing that we get here. And then we also get the ability to filter within that I cell. So again, in a base R, we might see, that you can do this with like the name of the table, $ column name, but we can skip that here and just put a filter in our I cell and get just those 35 rows that match that filter. So next I'm going to go into J and what we can do with J. And I'm curious, like, how are y'all doing? Too slow, too fast? Because I've got a lot of stuff here. We can go a lot faster. Looking for any comments. Everybody good? Everybody good. Well, Crystal's good. Thank you, Crystal. Okay. Could go faster if you need to. Good. Okay, we've got a faster, we've got a good, we've got a good. I'm going to go with about good, but a little faster. Okay. So now we're on to select and compute. Awesome, Jasmine. Good to have you listening. Okay, so select and compute is what we can do in the J cell. So, here, for example, we're taking that amount column, and if we just want to return the amount column as a vector, we would do this with our $ again in base R, contrib db $ amount. This is the equivalent syntax in a data table where we're just getting out the vector of amounts. If we want to return our amount column still as a data table with a single column, the way to do that is to use this list function within the J cell. So here, when we do that, we get a data table with a single column amount. Then there are a couple of ways that data table has adopted some of the syntax from data frames so that you can use similar syntax and accomplish the same thing. So this similar syntax will give you exactly the same thing as the list amount. So this is not meant to be confusing. This is meant to be so that you can use similar syntax to data frame and nothing's going to break. Another thing that you can do is you can specify a vector of variables. So here we're specifying just the list amount, and we are saving it in var name select. And then we're using var name select and calling that within the J cell with 2 dots in front. And that 2 dots in front signifies that this is our column names of interest. So when we run that, we get the same thing again, that 1 column of amounts. So these are all ways of specifying the same thing. The last example that I have here for J, where we're dealing with J alone, we'll get into some more complexity soon, is J is also where you do computations. So here we're going to sum the entire amount cell column. So here's the total amounts from all of 1980 election cycle that were contributed. So this is, again, the J cell where you can do selecting columns and computation. Let's go to our third cell, which is our by cell, where we specify things that we want to group by. So in order to group by, we have to do something in our J cell. So here we're going to sum the amount, and we're going to group that by contributor gender, which is one of the fields in the data table. So if we run that row, then we get the sum of the amount, which is here V1, because I haven't given it a name yet. And we see the sum of the amount by gender. And this first row is because there's some blank genders. There's 2 ways of specifying the syntax for this that are identical. There's using the list function and then dot. And that dot is a shortcut for a list. This is probably my least favorite thing about data table is that they try and make it easy and they provide sometimes a few too many shortcuts, so it becomes harder to learn the syntax. But that's my biggest complaint is, too many shortcuts. So when I'm writing code by myself, I will often use the slightly longer code just because I find it a little more, it provides a little more separation between each of the cells. But it's pretty common to just see this dot. So again, this alternate syntax will give us exactly the same thing, where we are grouping by the contributor gender. And the thing that we're grouping is the sum of the amounts. Any questions before we go into some helper functions and combining all of these things together with more complexity? Okay, I think everyone's good. Okay, so now we're going into helpers for subsetting and filtering. So subsetting and filtering, again, is what we're doing in that first cell, the I cell. And then if any of you are familiar with SQL, there are some helper functions that data table has incorporated that are similar to SQL functions. So I just dropped in a couple of examples, but one example here is we can filter to contributor last names that are like Trump. And then we get Fred Trump, Donald Trump, and these all have last name Trump or like Trump. I think, we see some that just are like Trump. They contain Trump in them, but they are not just Trump. And we can look at contributions that are between a range. So this will give us all of the contributions that are between that range. And there are 235 contributions between December 1st and December 2nd, 1980. And then this third one is in for character in. And here is either Bill or Hillary. So here we're looking for contributor first names in Bill or Hillary, and we are using that helper to filter in that I cell. And then if we go over to contributor first name, we can see these are this column right here. These are mostly Bills. There's got to be some Hillarys here somewhere. Well, I don't know where the Hillarys are. There's many more Bills than Hillary. Well, I found one earlier, so you'll have to trust me. There's some Hillarys in there too. And then I'm going to give a couple shortcuts for computations. Computations are in the J cell. And one shortcut that I use all the time is .n, which calculates the number of rows. So this is super fast to just get count of rows. Nice concise syntax for that you can use when you're grouping by and when you're subsetting, all of those things. Then there's .sd, which is probably one of the more confusing ones because I'm always looking at it thinking standard deviation. It does not stand for standard deviation. It stands for subset of data. So what this is saying is give me the subset of data where subset of data columns equals amount. So I will admittedly say .sd, I think, is one of the more confusing syntax parts of data table, and I almost never use it. If you are interested in learning more about it, there is an entire vignette in the data table documentation that is just about using this one shortcut. But you can also not use it like me. It does exist though. And then there's this third shortcut that I really like, which is .i, which gives you the row number for a particular observation. So here, if we want the row numbers for where column amount is greater than this huge number, we can spit out that vector of row numbers. So those are a couple of shortcuts that might help with some things. But now we're going to start putting some of those things together. So we talked about list and dot being equivalent. We talked about that when we were talking about the third cell, the group cell. But we can also use it in the second cell, the J cell. when we want to compute more than one thing. So here we have a list of computations that we want to make. And we can specify those pretty concisely with here we're giving it a name and then specifying the computation for each of them. So these two things are equivalent with list or the dot. And that gives us a single row of total, mean, and max amount. And again, the same when you have the dot. And you'll notice here that I am specifying the variable name. And when I did not specify the variable name earlier, it just said v1. So this is how to specify a column name when you are creating a computation or an aggregation. So now we're going to go with multiple groupings because just like multiple aggregations in the J cell, we can do multiple groupings in the by cell. So here we have these computations as we were doing before. We are only here grouping by contributor gender. So let's see what that looks like. That gives us 4 rows by contributor gender. And then what if we want to group by more than one thing? So we want to group by maybe contributor gender. What are our other choices? We could do contributor state. So if we group by contributor gender and contributor state, that spits out, these are the blank genders and the contributor states. So you can see that the syntax, once you get used to what goes in what cell, is pretty compact. So again, we're going back to those principles that we laid out at the beginning. We're looking for efficiency and speed and computation, but also efficiency in the amount of space that your code takes up. And just kind of like a compact set of code. We're gonna look at doing all 3 of these things together now, subsetting, selecting, and grouping all together in one example. So this first example here, take a second and take a look at it to see what it's doing. I'm going to talk through it with you. But we've got the I cell, the J cell, and the by cell all occupied here. So we are subsetting, selecting, and grouping. I'm doing all 3. This first cell is the I, and we're using some of our helper functions here. So we've got contributor first name is in Bill or Hillary, and the date is between December 1st and December 31st of 1980. So that is our subset. Then we're going into our computations here in cell J, and we've got the total amount, the mean amount, the max amount. Those are the 3 that we were doing earlier. And then we're grouping by contributor gender, which is what we were grouping by earlier. And yes, thanks, Shelley. It is character in, so that, yes. So that is essentially saying that it is in this vector here. So if we run that, then we are getting well, it looks like we don't have any Hillarys. But so we're getting one row here with contributor gender male, and then the total amounts, mean amounts, max amounts, for that fall into this filter. So we could add in here another, variable there, quickly expand that. And then we're getting our males in the states that the bills are living in, because we don't apparently have any Hillarys giving in the month of December. And again, the total amount, the mean amount, the max amount. So you can see everything kind of belongs in its spot, right? Like tidyverse, there's less, I would say, order, right? You can do mutations and selects and things and mix them up. And for me, it's always been a pro that data table has a very systematic organization where you have to put a particular thing in a particular order. Um, uh, so for me, that makes it more readable. This next example, I added a little bit of complexity where, in addition to specifying the contributor gender and the contributor state, I am also renaming a variable. So here we're creating a group by with a new variable, contributor gender equals female. And then we're naming it female. So that gives us a third group by that in this case is always false because this particular month does not have any Hillarys, but we have this third column in our group by contributor gender, female, and contributor state. Janine, can you use arguments and then the order doesn't matter? Argument names. Can you say a little more about what you mean with that question?
Yeah, sure. I mean, in tidyverse with something like ggplot, you can put, the X variable first and the Y variable name second, or you could put X equals the X variable name and Y equals the Y variable name, and then it doesn't matter which one you put first and which one you put second.
Yeah, that's a really good question. In data table, the order matters. So you can never in data table say, well, I want to use the J here and the I here. It always has to be, the space before the first comma is the subset, and the space between the second and third comma is the select. Like it's just, that is the way it is. But that's a really good question because it is very different than the tidyverse. So now we're going to look at some chaining examples. So what is chaining? Chaining is when you can take multiple sets of data table syntax and kind of stick them together in chains. So as an example, we have this data table here that we were using earlier with Bill and Hillary between, I expanded our dates here, so we'll grab some Hillarys. This is dates between January 1st and December 31st in 1980. So this data table is the only thing that it's doing is filtering. But for example, what if we wanted to do something in multiple steps? So maybe we want to filter it, save it, and then count the number of rows in it. So we would do that. We could do that in these 3 different rows of code here, lines of code. Or we can do it more concisely with chaining, where we have that first data table in the first set of brackets, And then we're doing another operation with a second set of brackets that applies to the result of whatever happens in the first set of brackets. So here, that chaining will give us the same answer as when we saved our variable and then applied our operation to our variable. So this is kind of a simple one, but you can imagine maybe we're doing something more complex where not only do we want to do a count, but we want to group by when we do that count. So here's the way you would do that with chaining. And then you end up spitting out the N, the number of rows, which is the number of contributions by men and women who are first name Bill and Hillary in January 1st to December 31st of 1980. So we're going to go into a little bit of comparison to tidyverse in a second, but are there any questions about thus far about the syntax and how you might do combinations of things and chaining? Okay, so everybody's good. Okay, we've got people following along. Now we're going to go into comparing to tidyverse. One thing that I haven't talked about much thus far, but I think I mentioned at the very beginning, a data frame underlies a data table. So any data frame syntax will already work with a data table. So we could take this, contrib db dt, and we can use the $sign and pull up any variable we want. We can use functions that you can use on a data frame, like head or tail, and use that same function. That's not a data table function. That's the original data frame function. And so any other packages that you're using, any other libraries where it requires a data frame input, if it's, you're running a statistical model, whatever you're doing that requires a data frame, you don't need to convert your data table to a data frame. You can just plug it right in. The other thing you can do is convert it very easily to a tibble, just like you can with a data frame. So here we are doing that and making ourselves a tibble. So now we have contrib db underscore tibble. And I'm going to give you a little challenge now. For those of you who are familiar with tidyverse, which sounded like it's quite a few of you, I'm going to give you a little challenge and give you maybe 5 minutes to try and tackle as much of the challenge as you can. And I'm going to switch to my slides because it's a little easier to see. Okay, so I'm looking for a data table or tibble that summarizes the metrics below for only women named Sarah. So we're looking for first a column that summarizes the number of contributions from Sarah's. Then we're looking for another column that specifies the number of contributions from Sarah's that are between $50 and $150. then the total amount of contributions from Sarah's, so this would be the sum of the amount field, then the total amount of contributions from Sarah's that are between $50 and $150, the number of unique Sarah's, oh, I called this the wrong variable name. Anyway, E is number of unique Sarah's, and then F, average number of contributions from a Sarah, so mean number of contributions per Sarah, and G, average total amount of a contribution from a Sarah. And I want those grouped by the state of the Sarah contributors. So that's the contributor state of this data. And then ordered by A, then by the alphabetical order. So ordered by column A, the number of contributions, and then by alphabetical order of the Sarah state. And we'll go for a little while and just see how far people get, maybe 5 minutes or so. And pick the one that you're most comfortable with at this point, which is probably tidyverse, and see if you can get a couple of these variables in there in tidyverse. And we'll compare it to what the data table code looks like and see which one is less crazy or more crazy. So we'll go until the 16 after and just give people a few minutes to write some code on that. And feel free to ask any questions in the chat while we're going. Okay. So I realized that wasn't too much time, but does anybody have a little bit of tidyverse code or a little bit of data table code that they want to show for progress in this little challenge here? Feel free to drop into the chat. Whatever you've got. I didn't quite finish it either. I challenged myself to write this in data table. Not seeing anything. So I'm going to start writing this in data table. We can write it together. So let me switch my screen. Okay, so we're gonna do the number. So we want this for only, yeah, it would take a lot of lines of code with tidyverse. So we've got our contribution data table. We want one data table that summarizes the metrics below for only women named Sarah. So we're starting with our subset, our I cell. So in that, we want contributors with the first name Sarah. So that's contributor first name equals Sarah. And then the next thing we want is we've got a whole list of column names. So we're going to use I'm going to use list here. We could just put the dot, but as I said, my personal preference is to show a little more separation between each of the cells. So we'll use list here. And then we're going to go num contributions equals, we've got our shortcut here. So if we want the number of rows, the number of contributions here, we can just do .n. And then we've got our B, number of contributions from Sarah's that are between $50 and $150. Again, this is another shortcut we can use is between. So we've got 50 to 150 num contributions equals, and I'm going to use a little hacky thing here where we want the number of contributions between something. So I'm going to do a sum of a Boolean where we want the amount to be between 50 and 150. So what this is doing is saying when the amount is between 50 and 150, so it's true. When you sum up a Boolean, it converts it to 1, 0. So we would be summing up the ones or the trues. And then we would get the number of contributions that are between 50 and 150. Then C, the total amount of contributions. And there we just want the sum of the amount. Then we've got D, 50 to 150 amount contributions. And that's the total amount of contributions from Sarah's that are between 50 and 150. So here I'm going to do a sum again, but I'm going to do an if else here, where if the amount is between 50 and 150, then we'll put in amount, otherwise we'll put in a 0. Then next we're going to do E, which is the number of unique Sarahs. I had a little mistake there in my variable name. Here, there's something that is super fast to do in the data table setting, which is to get the unique set of something within a data table is actually going to be one of the super fast things about a data table. So I'm going to do the length of unique contributor last names. So there might be some Sarahs with the same last name who are actually different people, but we're just going to take a little shortcut there. So the number of unique Sarahs we're measuring as the length of the unique contributor last names. I'm doing a couple little shortcuts here. Then we've got the mean number of contributions equals, well, the mean number of contributions is going to be the total number of contributions divided by the number of Sarahs. So this is the average number of contributions from a Sarah. So some Sarahs might have 3 and some Sarahs might have 5 and etc. So we're doing total number of contributions. So this is N over the length of unique Sarahs. And then we're gonna do the mean amount of contributions. And that's going to be the sum of the amount over the length of unique contributor last names. Then our last thing is we're going to group it by the state of the Sarah contributors, and we're going to rename that to Sarah state. So we're using our, we're closing out that J cell. Now we're adding the by cell. So we got by equals, and then we're going to do Sarah state equals, and then we're going to do our contributor state. And then the very last step is we want that ordered by. So we're now going to chain something in order to do the order by. So we're going to chain and then use the I cell of our second data table to order, and then we can use the variable names that we've specified in the first data table. A num contributions, and then by Sarah state. So went through that pretty fast, but wanted to show a more complicated example of, oh, Sarah state not found. Did I spell it wrong? Yep, I did. Sarah state. Sarah state. So how a complicated set of instructions, and JD, as you said, oh yeah, helpful error message too. Yep. It guessed for me. So JD, as you mentioned, it would take many, many lines to do that in tidyverse. So it's a pretty concise set of code in data table. And you can imagine there's other ways of doing it in data table where maybe you're doing more chaining. So maybe instead of reusing this denominator here as the number of unique Sarahs, maybe we're chaining and we're adding a variable in the second data table that uses the variable from the first data table. So this is there a package that provides more helpful error messages like this? Data table. So that was a data table error message, which is pretty awesome. So that is kind of some of the complicated examples I've got for you. Let's see, how are we on time? I do have more content. Don't know how long we go tonight for one of the organizers.
8 p.m. Central.
Oh, cool. Well, I've got more. So, the next thing I wanted to talk through is adding columns and copying data tables. copying data tables, we'll get to in a second, is one of the more complicated things about data tables, is when you're changing them and making copies of them. They don't always operate in the same way as data frames and tables, in terms of the variable names and the referencing each other, and whether you're changing things in place or I forget the terms in, computer science lingo. But all to say, things get a little crazy when you start trying to make copies. And there's a way to do it where you're making a copy, and there's a way to do it where you're just creating a second variable name pointing at the same data table. So we're going to look at some examples of that so that you don't get tripped up by this. So here, this syntax right here is how you add a column, specifically this little colon equal sign right there. So we are going to add a column that here says whether the contributor is a Sarah. So the way we would specify that is in the J cell. So we're kind of doing a computation here. We're adding a new column. We are going to add the column contributor is Sarah, where contributor first name equals Sarah. And then when we spit out the variable names here, we can see that we now have the is Sarah contributor column here. And then we can reference it just like we can with a data frame. Now we'll get into a little bit of the copying of stuff. So here, I'm adding, in this line of code here, I'm adding a column and I'm trying to make a copy of the data table. And what we'll see here is that it may not work quite as you expect, where, you might think, okay, well, I'm adding a column and then I'm renaming it, saving it to a different variable name. So maybe I'm not actually changing contrib db dt. But what we'll see is in this case, your new variable is going to show up in both the copy and in the original table. So here's the original table, has this column contributor is 50 to 150, and the copy has it too. And I meant to say contribution is 50 to 150, but close enough. So then what do we do if we're trying to make a copy and we want it to, here's another, I think, one that will trip you up is, yeah, this one's another way of tripping you up, where here we make the copy first, or we don't make a copy, we make a new variable name for our contrib db dt, and then in that second data table create a column. And we'll see in this example that column name contributor is Sarah 50 to 150 is going to exist in the second copy. The first copy that we didn't even reference here, but that up here we saved contrib db dt into, and the original contrib db dt. So this is something that can very easily trip you up, that you're not actually creating new data tables here. You're creating new names for the same data table that already existed, and then you're adding columns in place that is going to affect all of them. So I don't actually know how this operates in tidyverse and tibbles. But something important to realize when you're setting column names and exactly how these work. So if you really want to create a copy that's like a clean copy, you can wrap a data table in the function data.table, and it will create a new data table that will be a copy of your original data table. So here, new copy is what we're making here. And then another way of making a new data table is if you group by something and you're aggregating something, so you're no longer using the original structure and the original rows of the data table, but you've kind of created a new summarization that creates a new data table kind of underneath the hood. So that will be a new data table. You will also have a new data table created under the hood when you filter and save. So all three of these will be new data tables where you won't have that same thing happening where if you create a new variable name, it's created on all three kind of instantiations of it. So this is something that I didn't know when I was first starting to work with data tables and kind of tripped me up along the way. So this is, I put out to you as a place to be cautious. Any questions on that before we talk about deleting columns? Okay. So deleting columns, if we print out all the names of our new copy of contrib db dt, we'll see we've got contributor is Sarah 50 to 150 is our last column here. And if we want to delete that column, we just use our syntax to create a new column, but we set it to null instead of putting contents into that variable name. So then if we run this line, and then we run the column names of our, again, we'll see it's no longer there. The contributor is Sarah 50 to 150 is no longer a column name in that data table. And then if we look back in the names of the original data table, we will see that it is still a column there because this new copy that we made with the data.table function is a actual second data table copy, not a reference to the same data table. Any more questions? Cool. So I wanted to spend a few minutes talking about some things about data tables that are super blazing fast. Is there a way to delete a group of columns? That's a good question. I believe there is, yes. I'm trying to think of the best syntax for that. I think it's something like contributor, contrib db dt. I think what you would do is, if you remember at the very beginning, we had some syntax for if you wanted to refer to a list of variables by referring to their, we had like a var names select where we had, so we could do var names select and save in there like amount and contributor is Sarah. Do I have that right? Contributor. Yeah, contributor is Sarah. So let's say we've got our, then I think what we do, and I'm doing this a little bit on the fly, is I think we do their name select null. No, we do. I think. Do you want to see if it works? It may give us an error message, and it may or may not be a really helpful error message, or it may just not be. So let's see if this works. No. Okay. If this doesn't work, then I don't know off the top of my head. But okay, so that's not how you do it. There is a way to do it, but I think we would have to Google Stack Overflow and figure out the best way to do that. So it has something to do with being able to make a list of variable names and setting them all to null at once. So Jeremy, good question. Yes, there's a way to do it. Is there a way to create a row sum or row mean variable? Say a little more about that. Oh, do you mean like a row? Yes. So there is the row sums and call sums base R function that can be used within a data table. So you could like sum up across the data table by row. Is that kind of what you're talking about? Is being able to, yeah. So you can apply that because it can apply to a data frame. You can apply it to a data table and it'll work exactly the same way. And it might be interesting to time it and see if it's actually a little faster on a really big data table than it is on a data frame. Because sometimes these operations are faster on data table. So yeah. Any other questions before we talk a little bit more about merging and reshaping tables? So merging is another reason that I got into data table. We talked way at the beginning about fread, fast read. Data table merging is also magic. I didn't put in a lot of content here on this. I just spelled out some functions that are the ones that you really, really want to check out if you're working with big data sets. Again, fread is one of those data sets. Fread is one of those functions that will help you even if you're working with a really small data frame, a really small data set, because it will do all of the type inference and inference of separators, inference of, quotation type, and all of that will do it for you. Merging is one of the things that you just do with data table because it's blazing fast. If we take a little look at, oops, the merge data table, oops, here. What I'm gonna do is, here we go, contrib dbdt. We're gonna merge. I'm gonna do a little live coding for you. We're gonna merge with the merge data table function, we're going to merge a table to itself. So the parameters here are X, you take one data table, Y, which would be our second data table, and then we're going to specify what we're joining them by. You may have done this with a data frame with other data objects before. This is where I suggest that you grab a really big data set and try tictoc with it, because it'll really blow your minds. But so here our X, we're going to say is contrib db db dt. And let's say our Y is, maybe we're gonna summarize the amount given by state. And we're gonna do a by equals list by contributor state. So we've essentially got our original data table, and we're merging it with a data table that we've created as an aggregation of that original data table. So this is going to have one row per contributor state. And then we're going to join these by the contributor state variable. And this is something where I love the syntax again, because to me, this remains really readable. Where if you're thinking about doing merging with tidyverse type syntax, things get really messy really fast and really hard to read really fast. And data table just remains, for me, a simpler way to read the code. So then what do we get with our table, our merged data table? We get a new statewide amount column appended to our original data table. And you would see, doing this on something like the 2016 data set, that it would be super, super speedy. Some other examples here. F overlaps stands for fast overlaps. This allows you to do some more complicated merging and joining, where you're not necessarily merging by equivalent fields. So in this situation, we specified we were merging by the contributor state field, and we were doing that based on matching contributor state fields. The F overlaps function lets you merge based on overlapping time periods, for example. So you could take two data sets that are time-based and say that you want to join them together when the months in one column overlap with the months of another column. And it can get super, super complicated. And F overlaps just handles it super fast. So if you're doing any sort of time-based joining, if this is a problem you've encountered before, you'll know that it's not straightforward to code, and you often have to, like, kind of code up some custom functions. You really want to check out F overlaps. And Laura, I know you do a lot of time-based stuff at work, so you should check out F overlaps. So that's another thing to look at. It's one of the functions that's been in the data table library for ages, and is another function that has converted people to this library in some cases. And some of the functions that you may be familiar with from the tidyverse, like melt, have faster implementations in data.table. So this is another thing to check out with tictoc and some of these other libraries where you can time things. So more things to check out, but hopefully what you've got so far is a good basis for at least being able to take advantage of the super, super fast fread, and having an idea of the rest of the syntax that you can use to be super concise and super spiffy in all of your data manipulations. The last thing I've got here for you is a couple of online resources. The data.table GitLab site has a lot of activity on it, a lot of helpful vignettes. As I mentioned, they have an entire vignette just devoted to the .sd shortcut. So they go pretty deep. There's a very active community around data.table, so you'll find lots of helpful questions and answers on that site also. One other thing I want to mention is that some of you who have Macs may have seen a warning message pop up when you loaded the library that said something about single threading. Not sure if any of you out there are Mac users who might have seen that. If you are, there's a special set of instructions for installation that will explain to you how to get beyond single threading. And what that does is allow you to take advantage of some of the parallelization that the data.table package will do. And go even faster. So for some of you who are seeing different runtimes, that might have been because of this special instruction that you need to go do for data.table on a Mac. So with that, that is what I have for you all today. Any final questions?
Okay, so it looks like we're seeing a lot of thanks for the talk. Really appreciate it, Susanna. Yeah, so I think we're all inspired to go check out data.table and branch outside of the tidyverse a bit.
Yeah, well, I hope I've converted some people, at least to fread. Fread is the best part, but there's lots of other good things.
Sure. Okay, well, we'll end a bit early. So thank you all, and we will see you, hopefully many of you, in our next meetup in the spring.